Good afternoon to everyone. This session will be handled by Mrinalini ma'am. He is working in DigiToad technologies. And the session topic is data acquisition with Labview. Okay. Now the session over to you, ma'am.
Thank you, sir. Thank you for the introduction. So I am Mrinalini Barik, application engineer in DigiToad Technologies Private Limited. So today, has sir just tell the topic of the session. So today I will be mainly focusing on the applications or on Edge AI and using the STM AI ecosystem. Like STM, as we know that it's an worldwide company which deals with your softwares and hardwares in field of semiconductors and other hardware products. So it's a worldwide award-winning company. So the ecosystem which we deal with an STM AI. So today we will be focusing on that. What are the hardwares and softwares which comes under the ecosystem of STM, ST microelectronics, and we will be seeing one application has anomaly detection, how we can build our model using the STM ecosystem. So now we can see in industry our embedded system, machine learning, AI, all these topics is booming, suddenly booming in the industry. So like as we earlier know that we had standard programming, it's a traditional based programming where earlier the coders used to write the code and they used to run and they will get an output, desired output. But now in the industry, we have machine learning and other applications which will take the input, it will build a model according to us, and we will get an output which we want. So it makes the working process easy, efficient, and it has many security factors. Like you can get the desired output as well. So this is this is the main difference between a standard programming and a machine learning programming. So coming to the AI approach, the industry is slowly going to the AI approach. We can see that all our day-to-day life products, which are based on AI, it's an fully automated artificial intelligence product. Like we can see one example of washing machine, ACs. So all these products in our houses or in some industries also we are using. So these are all based on our AI approach. So we have, talking about that, we have thousands of data centers which are which helps to analyze the data, store the data, and computing the data. So we have thousands of cloud data center where we can store the data, and we have millions of edge nodes which uh, creates or which acts as an IoT gateway. It's an also micro data center where we can which makes the bridge, which fills the bridge between your devices and your cloud. So it's an it is also known as edge nodes. So we have millions of edge nodes in the AI industry, and there are billions of devices, the things, edge things, which are which acts as a smart device when connected to AI approach. And these can be these all things collect the data in a real-time application. They can be connected to any of the microcontrollers and any of the edge nodes, and they have then ultra low power devices and sensors. So these devices act as a smart device. So like our smartwatch, like AC, pumps, washing machines, our drone system, all these devices are known as edge things, which will be acting smart after giving an AI approach. So what are the advantage, like why we will be using artificial intelligence at edge? So artificial intelligence, we can see that it's an ultra low latency. In real-time application, it uses a very low power and it is more reliable. Like we can connect to any kind of microcontrollers, we can do any kind of a development project for our using this AI intelligence. And main thing, doing some project, we must see that it has in security, like it has in secure, like the data is been secure and it has no breaching of the data. So this is the main factor we need to see that with the, before starting any project. So this gives you a security of data, like clouds cannot share, or they cannot erase any of the data. So this is the main factor of artificial intelligence. We have privacy. If someone has its own design and development, they can have the privacy to the designs, and it is unsustainable on energy. It uses low power consumption, and lastly, it's an better use experience. Users can interface it very efficiently and very easily. Nothing very advanced level is required to configure and to use this artificial intelligence. So what are the real-time applications which we see in our day-to-day life? So first, there is home maintenance, which here is given an example of a dishwasher. In homes, we can see that like we have some dishwashers which will be automatically working. So we just have to put some dishes. It will automatically clean your dishes and give the output in the sense it will clean all your dishes and give it back. So this is the in home maintenance, we can use this dishwasher for edge artificial intelligence. So this is one example of a home maintenance part. There are many home maintenance has ACs, which is IoT based. It's an artificial based. Before reaching your home, you can turn on your AC, or if you're leaving your home and you forgot to turn off your AC, so automatically you can like use your phone, like you can create one app and you can install in your phone, and you can just off it while driving to the office if you forgot turning off. So this can consume the power, like it will not it can save your power. So all these home maintenance applications, they are in industry right now. We have in industrial maintenance, we can go for pump, like in big factories, industries, there are big machines. So if something goes wrong in your machines or in your pumps, so to check that what is wrong or how it's been failed, so we can use this artificial intelligence and we can check what is the error, what is the problem in your machines and pumps. So like predictive maintenance we can go for. So all these things can be done with artificial intelligence. One more example has security in homes, in offices. We need to apply and security system where we will be going for, like if some unusual noise is there, so it can easily be detected. It can like the person in the owner can be like it can be he can be alerted that someone has just entered their house, and they can be alert and they can just see, like they can measure, like take some measures, and this can be like it affects a security system very positively. So this is an use case for security. We have smart cameras as well. There are smart cameras in outside your doors, like outside your home doors, which if someone is entering your home, so first that face will be recognized. Then if that owner allows that, yes, I recognize this person, then only the door will be opened. So this is also based on your artificial intelligence. Um, the last example I would like to give is people counting in malls, in restaurants, or in some closed area. If some people are waiting for their number to come, so it can, like, this application can save the time. Like, it can inform the people that the number of people which are present. So after, like, I will like to give an example. If I'm going to a restaurant and I will get an alert that before me 10 people are there, so I need to wait there. So in that 10 minutes I can finish my work and I can reach there. So it can save my time as well. So this application can help to save your time. It can tell what is the count of the people in any closed area, so it can reduce your waiting time. So these are some main examples using edge artificial intelligence. So, and now talking to the STAI ecosystem. So in STAI ecosystem, we have one software, which is Nano Edge AI Studio software. It's an automated machine learning design solution tool, which helps you to build your machine learning machine learning models. So this tool will take your data, it will build your model, and it will give you the output, like output in the sense your model. So in this studio will help you to work very efficiently, very fast. You can get your results very fast. So, like, if you go for manually collecting the datas, or if you manually build your model, it will take some time. But this tool, it can automatically collect, like, it we have to give the data, we have to collect the data, then we have to provide it into Nano AI Studio, and with that data, it will combine and it will form a best ML model which is suitable for your development. And this
Pranali,
ML model,
Pranali,
hello.
can you just help us to understand, because most of us are mechanical engineering professors and
Yes, sir.
okay, can you just help us quickly some sort of a video or something how Nano Edge AI Studio?
Yeah, sure, sir. Like giving you brief about this ecosystem, I will give some use cases, show the videos of some use cases where we can use this machines and all in this STAI ecosystem. Is it fine, sir?
Yeah.
Yeah. So, like, this will create your model and give you the best ML model. So here we have an ultra memory efficient flash and RAM. It gives you 100% accuracy, and it gives you the best model. So this tool will help you to build your machine learning. So if you want to create a machine learning project for machine, like fault detection in any machines, so this you have to give some data, like I will run one machine and I will give like some kind of disturbance in that machine. So it will collect a normal data and a abnormal data. So after collecting these two types of data, it will build a model, machine learning model, and based on that data, it will provide you the best model. So after that model is prepared, built, it will give you the accuracy, how much accuracy got that model of. Like, it can be 96, 95. So, like, ideally, if we go for checking our accuracy, 95% is an ideal accuracy for our models. Like, if your model is 95% above, then it's good. You can carry forward for your validation part. So validation is like, first part will be your testing, then your validation, that my model is working properly or not. So this is the work of Nano Edge AI Studio. So as sir mentioned, I will just show one video, one Just a second. Just give me 1 minute. I will show you the video.
Start for testing multiple nodes via cloud dashboard. Before going to the demo, monitoring method.
Excuse me, ma'am. The video is not shared. Hello, ma'am.
Yes, sir. Just 1 second, sharing it. So this is an ST's Industry 4.0 for condition monitoring and anomaly detection. So
First, a few words about the context we're in today. We're already seeing a rapid evolution in the industry, where we are leveraging a wide variety of solutions to render production more efficient. The terms we hear a lot about are Industry 4.0 or digital manufacturing, for example. The driving force behind are clear: energy efficiency, secure and safe production, and maintenance optimization. Being capable to monitor and detect equipment malfunction and implement fast corrective actions has a dramatic impact on safety, quality control, operational costs, and finally, if you refer to electric motors, on energy efficiency as well. Technology breakthrough like sensor miniaturization, high performance, and low-cost microcontroller RTAN-key connectivity are essential as they allow real-time acquisition and sophisticated processing like AI at the edge and digital twins. In this domain, one of the key applications is indeed condition-based monitoring and predictive maintenance, which brings me to the main points of this video. We believe that developing condition monitoring is the first and fundamental step towards implementing a predictive maintenance strategy. In this context, the field of application is very wide, going from factory automation to transportation to energy and oil industries. We can summarize the main challenge as follows. First, data management architecture. Based on the physical system, we need to define the architecture that enables the gathering of the right data at the right time, which means defining the data logging capabilities, the latency to log the data, and therefore the connectivity. So we need to build up the right sensor nodes by choosing the products that fit better in terms of performance. For example, the microcontroller or the sensor or the analog device. Then we need to implement processing strategies that guarantee power consumption, security, and therefore the right partitioning between edge and high-level processing happening in the cloud or on company premise. In this demo, we are going to showcase some of the possible implementation that help the designer to solve those challenges. The demo is composed indeed by 3 elements that are driven by a touchscreen display based on STM32H7 Discovery Kit with Touch GFX software utilities. The three scenarios represent use cases enabled by vibration analysis, ultrasound, and environmental sensor. Let's see the demo working. This part of the demo will show how it is possible to stream all the data from the smart sensor node that we call STWIN. STWIN stands for Industrial Wireless Sensor Type, and it's equipped with 9 sensors for 16 degrees of freedom. The kit features a battery power core system board with ultra-low power STM32L4 MCU that receive data reflecting the operating condition of an industrial machinery from a range of advanced ST environmental and motion sensors, including the state-of-art ISM330DHC inertial measurement unit with machine learning capability and vibrometer IIS E3WB. STWIN comes with a complete ecosystem, including software for high-speed data logger and interoperability with Unicode UI. Let's turn on the device. And here we see the UI showing all the data streaming. This tool is great for helping engineers in gathering insights and test their own algorithms. The UI is available also as open source and contains some firmware example and high-speed sensor data logging to SD card or via USB. Let's move to the second use case. Here we show the STM32MP17 DK2 acting like a gateway with process capability that collects wireless smart sensor node connected to a motor. To emulate a workflow where anomaly detection works on the edge, we are using IO-link serial communication, and the TINI smart sensor node STEVAL BFA001B. Data is streaming to the MP1, which detects the anomalies and sends the event the data in a cloud-based application. The event is communicated and displayed in real time. And further analysis or algorithm development could be done to classify or implement action on the edge, also by using AWS Greengrass. Let's turn on the device. Here we see the normal behavior of the motor. Let's simulate a fault. Now you see the event that is shown, and data are streamed as well. Finally, let's move to the third use case, where the anomaly detection capability for a bearing. Inference works on the edge in the L4 MCU of the STWIN in an ultra-low power consumption mode. To emulate a workflow where anomaly detection works on the edge, in this case, we're using a Wi-Fi connection that is enabled when an anomaly is detected to stream the event. And data in the cloud-based application developed always by using AWS service. The event is communicated real time, and further analysis or algorithm development could be done to classify or implement actions on the edge. And the event is shown in the dashboard, and the data are streamed successfully. The L4 Plus MCU has different inference capabilities. ST has developed partnership with software companies and at the same time enabled the programming of neural networks through Cube.ai software that is part of STM32CubeMX. All the demo components, the hardware, the software, and the cloud application are available at st.com. Please visit our webpage.
So this is a small kind of a demo for condition monitoring and predictive maintenance. So just a second. In this demo, you can see like for pump, they have tested anomaly detection, anomalies, signals, normal or abnormal. If it's showing normal and abnormal signals, we can detect the anomalies in any machines, in any pump. So this can be done easily using ST's AI ecosystem and artificial intelligence. So first, explain Nano Edge AI Studio. It's an automated machine learning tool where we can build any type of ML models. It can be of for an anomaly detection, for your signals, like 2-3 signals if you want to go if you want to build your model, or if you want to build a model for a prediction or a regression based model. So these all models can be developed in your NanoEdge AI Studio. Now moving to one more STAI ecosystem software, which is STM32Cube.ai. So it's a very good software which helps you to, like, after creating your ML model, after using your NanoEdge AI Studio, if you have created your ML model, so that ML model, if you want to deploy into your microcontroller, any kind of microcontroller, if you want to deploy, so for that part you will be using STM32Cube.ai software. And for that, like, you must have heard that there are different machine learning algorithms which can be developed, which like CNN, ANN and all, and which can be like, we can create a Python based model as well. So for building a Python based model, if we want to deploy into our microcontroller, this makes STM32Cube.ai makes it very easy. Like, it can easily deploy your machine learning model to your C program, and it can deploy into your microcontroller. So if you are going for your Python based models, like you can use TensorFlow Lite, Keras, PyTorch, MATLAB. So any programming, if you create a model based on these applications, AI frameworks, you can easily develop, deploy into your microcontroller board. So this is one of the Nucleo ARM Cortex M4 board, which is given by like STM Microelectronics. So this is a 32-bit microprocessor.
Excuse me.
Which, yes, sir.
Ma'am, I think PPT is not shared. Did you share PPT? The screen PPT is not. Okay. Yeah, okay, ma'am. It is visible now.
Okay, sir. Sorry, sir. Like, just little bit glitch.
Okay, okay, ma'am.
So I will again explain what is STM32Cube.ai. So here, as I just told, that if you are working with your different AI frameworks model, like if you have developed one TensorFlow or a Python based model using different ML algorithms or deep learning algorithms, so that model can be deployed into the microcontroller using this STM32Cube.ai software. It is an optimizer which converts your Python based model or any AI framework models to your board, microcontroller board. So some examples for AI frameworks are TensorFlow Lite, Keras, ONX, MATLAB, PyTorch. So these all AI frameworks can be deployed into your microcontroller board. So it makes, like, it can easily, like, if you use these two softwares, so it can easily build your model, it can easily be deployed into your microcontroller, and in last you can get an standalone project which can be transferred, like which can be moved here and there. So this is like a complete project developed by an STAI ecosystem. So this is one of the board which STAI ecosystem provides. It's a Nucleo ARM Cortex M4 board. It's an embedded board without any IoT interfacing or Bluetooth interfacing. It's just an embedded board, and it is an 32-bit microprocessor, and it can be connected with different sensors. It has all the communication protocols as well, I2C. If you want a motion sensor to be attached, you can easily connect your motion sensor, accelerometers, like all these sensors can be connected to your ARM Cortex M4 board. So now we will be seeing one use case as anomaly detection. So by the name, we can figure that anomaly detection is like something anomaly we have to detect, like some fault or some problems in some device, we will be detecting it. So anomaly is a technique which provides the ability to machines to understand if the signal that is given is normal or abnormal in data. So like if giving an example, if in a big industry, in big factory, one machine is working and continuously it's in continuous process, but suddenly your pump or a machine stops working, like some sound is there, the increase in temperature is there. So that abnormality in the data, to detect that, we can use this anomaly detection algorithm in our machine learning. So this makes your because if someone will be like if we have to check it manually, then it will take some time, because people will go check it, should like he should remove all the parts and check what is the problem. So it will take some time, so it can like reduce the efficiency of the work, it can stop the work. So for that thing, we can use anomaly detection in our real-time application, and we can easily get to know what is the problem inside the like motor or a pump. So for that, this is an the normal anomaly detection, as I told, is a technique which can provide the ability to the machines to understand what is normal and abnormal in the data. So anomaly detection is an unsupervised data processing technique. Like we have to give the data, like that data will be stored, it will be given, and then it will and abnormal. So it is an unsupervised processing technique. So has like the applications, like the real-time applications related to anomaly detection, its operational efficiency, we can get to check the risk mitigation, product quality, security, and optimal resource utilization. Like if the product is working properly or not, if the quality is good, like if any risk is there, like if the temperature, the motor's temperature increases, so it can burst also. So for that, before the problem is increased, we can get the alert. The factory people can get the alert that some abnormalities is there in your this pump, so it can be rectified before some big occurs. So this technique we can use in our factories and machines, like in different industries as well. So like I'll give a small demo kind of a thing for anomaly detection. So the objective of the demonstration will be like it is basically on ST microelectronics technology, and we will be using motion sensor MPU6050 vibration sensor. It is an 6-axis motion sensor which can get your gyroscope values as well as your accelerometer values. So it's an 6-axis vibration sensor, vibration and motion sensor. So we will be connecting our motion sensor to a fan. So here I have used, for a demo purpose, I have used a fan here, but we can check it for a pump or a motor. So we can go for any things, like any other big pumps and motor. So we can check the anomaly detection for that also. So we will be monitoring and identify the abnormal patterns in a real-time application. So this is the setup, experimental setup. My MPU6050 vibration sensor, which is connected to my STM board. This is my STM board. And my sensor is connected to the fan, DC fan, which has 3 different speeds. So basically, we will be in this anomaly detection, we will be checking for speed 1. Like for speed 1, we will train the model. If we train the model, so if my speed 1 is my normal data, like there is no abnormalities and some sound or some vibration is there, then it will change it to abnormal data. So that we have to give it. Like in this case, we have to give it, but if you check for a pump or a motor, like in industries, we can directly connect our sensor to the pump and motor, and it will automatically check if some vibration is there, some sound is there, like some gears are making some sound. So all these can be checked using anomaly detection. So talking about the workflow, how this model works. So the first part in every AI development project, first part will be our data collection, like the data preparation part.
ஒர்க் அவுட் பண்ணுங்க, ஒரு டைம் இல்லை, 3 நாள் இருக்கு, சும்மா இருப்பேன்.
Can I continue?
Yes, ma'am, you can continue.
Yeah. So Edge AI, for the first part, the first step will be always to collect your data. Like you have to collect the data, you have to process it, and then like so after processing the data, we will move to our second part, which will be our model development part, where we will select our model, select our algorithm, we will train our model, and after that we will be testing if it's working properly or not. So that is our model development part. If it's not testing properly, then we have to rectify it. Like we have to again go to our first step, we have to take the data again, and then we will be building our model again. So this is our second part. So the last part is our implementation part, where we will get a model, a ML model, and that ML model will be deployed into our microcontroller. It will be interfaced in your microcontroller, so you will get a standalone project, and you can easily develop a project which can be like you can test your model. Like here I will create a standalone project with attaching all my batteries and all, giving it power, and then it can be used in any application for your predictive maintenance or controlling or monitoring anything. Like for detecting normal abnormalities in machines, so it can work for any of your model. So anomaly detections workflow. So we can see we have in the PC side and how to connect into the microcontroller side. So coming to the PC side, where we have to create our anomaly detection machine learning library. So we can see that we will be opening our NanoEdge AI Studio software. We will be giving some signals like normal signals and abnormal signals. We will be giving it to our NanoEdge AI Studio. We will be selecting our anomaly detection class because we want to check for the detection abnormalities of detection. So we'll go for anomaly detection, and then we will be after training, developing and all, we will be getting our ML library. So after getting that ML library, that part, now the last part is our deployment part. So on the MCU side, on the microcontroller side, we will be deploying the ML library into our microcontroller part. So in our microcontroller part, after the deployment is done, we will have two cases, normal and abnormal case. So if I give my normal signal, it will then normal signal. And if I give some disturbance or some vibration, some sound, it will detect as my abnormal signal. So this classifying or this detection part in your microcontroller part will be your last part after the deploying of your ML library. So as I mentioned, model A is your abnormal signal. Model B will detect your normal signal. So the model is already trained. It's already trained in your PC side. Just we have to deploy it into our microcontroller and we have to detect it again in our real-time application. So what is the outcome, like what is the final result we get from the anomaly detection technique? So the first one we get has the ability to detect the anomalies in real time, which can decrease the, like it can decrease or it can give you alert on fault detection. And the second point we can get to know what are the faults or what are the errors or what are the malfunctions in any of the products, in any of the machines, in big industries, because the industry or a factory works on these machines. If some machine is not working, it can stop the productivity. So for that, if we uh, ec- if we connect our anomaly detection technique to that machine, like if we implement that, it can, like this stopping of productivity can, like it can decrease, and we can in timely basis we can get to know which machine is not working properly or not. Like we can uh, before 15 minutes or before 20 minutes we can get to know that, like like this work can be properly maintained, and if some error is there, it can be easily and it can be fast, like the error can be solved very fast. So this is the way we can implement our anomaly detection technique, and the final output we can see for like we can detect the abnormals and normalities. So this will help, this will create the anomaly detection technique. And lastly, we can also, if you want to, like lastly comes the cloud connectivity part for this technique. Like if you want to store a data of, or you want to share your data, like transfer your data to a cloud connectivity, you can easily connect a cloud connectivity base, and you can just transfer your data to cloud. So if I want that that factory owner should get an alert of my which machine it's not working properly, or which part it's not giving it's giving an abnormal signal. So that part, that information will be alerted to the owner of the factory. So for that, we need to connect our cloud connectivity to that, and we can easily create a full project out of this anomaly detection technique. So like, and the use cases of anomaly detection we can see in industrial machinery monitoring, motor fault detection, pump performance monitoring, equipment condition monitoring, and health monitoring. It can be used in any of your machines, even in health monitoring system also. Ultrasound systems are there, MRI systems are there. So there also we can implement our anomaly detection technique. If for X-ray, like we can talk about the X-ray system. In X-ray system, something the machine is not working properly, so it will give a beep sound or it will not process. So that can be detected from our anomaly detection technique. So these are some use cases which can be implemented using anomaly detection technique. So this is the workflow for anomaly detection for predictive maintenance. So like this is a machine. We can see the workflow here. This is a machine which is connected to our machine learning model, we will get the data. We will create one machine learning model. So that machine learning model, if something is wrong, so it will send the alert to the technician. So technician can easily go and it can easily give the service to the machine. So after the machine is rectified, so it can, the normal signals can be get. So before that, the machine learning model, which if it gives an anomalies, so it will be sent to the like anomalies or a normal data also. So this all thing will be stored in your database, and that database you can get it into your dashboard as well. So that dashboard, if that alert system technician or the owner has, so it can, like, he can easily go and detect what is the problem, and he can solve the problem at the same time itself. So this is a very big application, or it can reduce so much efforts of a worker, or the people who are working on factories and industries. So this is one of the method, anomaly detection method, which can be used for motors, pumps, big machineries and all. So this is the presentation. So like I will show you the demo. So the demo which I just showed you, the demo setup, like this, the fan and the board. So a small how this anomaly detection works. So this will be like, I will show you this thing. So before that, any like, if any clarifications or any doubts, like.
Okay, thank you for the presentation, ma'am. Any question from participant sides?
Yeah. Can you just tell us where it is used in, is it implemented this particular, what we call MCU? Is the
Yeah.
any of the OEMs, automotive OEMs?
Automatic OEMs, like it can be done in any of the microcontrollers. So like it can be your AI microcontroller, embedded microcontroller, IoT based microcontroller. So it can be, but
One more thing. Suppose what
Yes.
would be the cost? Suppose now here you are saying, what is the board you are using? ST32 Nucleo.
STM32,
STM32.
STM32 Nucleo board. Yes, sir.
Yeah, which is having the AI enabled, right?
Yeah.
What is the cost difference between this one to the simple plain one without AI or ML?
So you're talking about an Arduino board?
Yeah, Arduino board.
So the difference is, like, Arduino board is used for very small projects. So this AI part, like the cost is very huge, not huge. Like this board, it will be cost around 1,200 something, but it has some facilities, it had some advantages which your Arduino board will not give. Arduino board is just to connect some sensors and get the data, and you can send that, like, if it's a normal Arduino board, you cannot.
Okay.
You cannot.
Okay, that's fine. Yeah. Can you just tell me, with the AI-enabled MCU versus simple MCU, what is the cost difference? Suppose X is the cost of current MCU, which you use from particular application. Suppose you wanted to enable the AI. Okay, what is the difference in cost?
Cost. So as I mentioned, this STM board,
Leave the board. Leave the board. I'm asking simple IC.
Okay.
Simple IC cost.
Stuff, semiconductor, no?
So like it will be, the difference is little bit, but exact I'm not able to, like, I can't give you the exact price.
Suppose X is the cost of existing MCU, which is used for one application like instrument cluster. Instrument cluster is having a microcontroller which is costing X rupees. Now I wanted to enable the AI features in that so that I can use the whatever you explained, development process,
Okay.
so I can
Yeah.
predict.
Yeah.
So what would be the cost of the AI enabled chip? Is it 1.5x or 2x or 3x or 10x?
Sir, I think 1.5 only.
Okay, thank you. And
Only
can you
because
just tell me, so AI applications in automotive, you're not implemented, you are only just proposing, right? So
yeah.
have you applied any other areas like you said home IoT applications, or
Yeah,
have you
IoT.
applied?
Yeah, like we have like we were applied in a like home maintenance kind of thing, where temperature and humidity, so like to getting the atmospheric temperature, like the room temperature, and we will be getting that, and that can be sent to your AWS cloud also, and it can detect in your, it can be like it can be alert if something is there. We got to connect a gas sensor also, where we can see if some like burning gas or some chemical, some different gases are forming. So that part also we did for home maintenance and all.
Okay, thank you.
Okay, any question from online participants? Okay, thank you, ma'am, for your
Value.
ma'am. You said one demo video is there. We can wind up with
Yeah.
that.
Yeah.
Okay, thank you.
Just a second, sir. I will just share my screen.
Okay, ma'am.
So this is my Nano Edge AI. This is our Nano Edge AI Studio software, where we have anomaly detection. One classification as anomaly detection, N class classification, one class classification, N class, and extrapolation. So in this, we can, as I told,
What is the meaning of one class classification and N class
meaning, sir.
classification?
Yeah, one class is basically if you're giving only one signal, like to just explain you in an example form, I want to just classify my normal like surrounding noise, or only I'm just giving my ambulance. If I want to classify the noise which I'm giving, it's an ambulance sound noise. So only for one class it will be classifying. If I have only one signal to give, then it will be used one class classification. If there are more than one signals, then we will go for N class classification. As like one project is there, audio classification for different noises: baby cry noise, ambulance noise, and normal surrounding noise. So if these three signals are there or four signals are there, so we can go for N class classification. And after building building the model, we will get to classify what sound it is giving, or what sound it is like it is classifying. So extrapolation is our prediction or a regression model, where we will build a model which will predict something. So if we are giving for humidity, then it can predict the temperature of that part. So this we can this kind of models we can create in extrapolation. So here, my anomaly detection will be done in 7 steps. First part, your project setting, like we have to give for the project setting and what board we are using, what sensor we are using. So all these we have to give it in the project setting. Then the second step is to collect your regular signals. So regular signal is nothing but your normal signals. So I will just open the camera.
What would be the cost of this Nano Edge AI Studio for a personal use versus institute training purpose?
Sir, this is a software which is based on your license key. So if you go for like if you want your personal, if you want to use the software for your personal use, so you can directly go to your STM website, website, and download your Nano Edge AI Studio, and you will get one license key for that. So after giving that license key, then you can use your Nano Edge AI Studio.
So that is free of cost, you are saying, personal use?
Yeah. This software is free of cost, sir.
Okay.
For the institute, ma'am.
For institute, like if for institute you want to go, so you can take like you can generate one license from it, and that one license can be used in your 25. So after generating one license key, that one license key can be used in your systems, like how many systems you want to be installed. So that many systems it can be used.
You can continue, ma'am. Hello?
Yeah. Yes, sir. So this is the setup. This is the fan. And I have connected my MPU sensor, MPU 6050 sensor to my fan, and this is our STM board. So we have connected to the sensor, and the sensor is connected to the fan. So instead of fan, we can use a pump or a motor or any big machines also. So just to what is the normal signal we will be giving, I will just show.
You are explaining the studio, right?
Yeah, like
Okay.
how to collect the data, like how the normal data is being collected and what is the abnormal data. So I have started my a fan. This is my P1's fan. So after collecting, I will collect, if I want for 200 signals, 200 samples, I will collect my 200 samples from this P1 fan. So this is my normal signal.
We are not
And
able to see
there is
that. We are not able to see that. Where is the, can you use your, what do you call? Pointer.
Clear alla.
Can you see, sir?
Yeah, ma'am.
Yeah, so this is the fan, my microcontroller board connected to the sensor, and the sensor is connected to the fan. So instead of fan, we can use motors, pumps, and all the other machineries as well. But here for demo purpose, we have kept the fan here. So I have the first speed. So it's this data is my normal signal. It because there is no vibration or no sound is there. But when it comes to my abnormal signal, when I have to collect my abnormal signal, then I will give some disturbance over. So this is how I will collect my abnormal signal. So first part will be my regular signal. I will collect my data. So this is my normal signal. I have collected 200 number of lines, 200 samples of normal data, and then my abnormal data. So my normal data was blue and my abnormal data was red. So I have collected again 150 lines of normal data, abnormal data. So after collecting these data, I will move to my benchmark process. So the benchmark process is the fourth step where we will see the accuracy of the model. So after collecting these two signals, the model is being built. The benchmark process will run for 10 minutes or 5 minutes, and it will give you the best model, and it will give you the accuracy of your model. So as we can see, this score, which is mentioned here, is my accuracy of the model. So here I'm getting as 96.62%. So this is my average, like accuracy of my model, which consists of your balanced accuracy, RAM and flash. So benchmark will give you the accuracy of the model which has been created just now. So after this, we will see that some 20 iterations, it has given 20 iterations, and my signal samples, which is normal and abnormal. So we can see if I open my result part, which will give you some libraries. So this anomaly detection will give you some ML models such as ZM, IPCA, MML. So all these models will be ML models will be created. So out of these models, the best model, the build model which is just created, it will give you the best model. And we can get a confusion as well. So after this, I will move to my validation part, the fifth step, which will just tell you the models and what is your model and which model, ML model it is used, what is the accuracy, your flash, RAM. This is kind of a report part. And next part will be your emulator part. Emulator is the part where we will be checking if the model is working properly or not. So I will initialize my emulator. We're taking our data from serial port. So we'll select the serial port. Okay, so this is I have to first run my, like, just a second, sir. Give me just 1 minute. I'll just connect the board. So when we get the model in the Nano AGI part, so to check the model, if if it's working or not, deploying into the Nano Edge deploying into our microcontroller. So for deploying it into the microcontroller, we will be getting the ML library that we will be giving to our microcontroller. So there is one more software, STID, where we will code that's the coding platform, C programming coding platform, where we for our interference part and the data logger part. So here, after that, we will be, after it's like it is deployed into our microcontroller, to check the result, if it's working properly or not. So first we have to train our model. Like, this is my normal signal. This is my normal signal, which I showed. So my fan is running at P1 speed only. So this training cycle will go till 40. Like, this training cycle, I have to give it. So after the training cycle is completed, you can see the similarity score is 100%. If I give some disturbance, then the similarity percent is 0. So this 0 signifies your abnormality. This 0 signifies your abnormal data, and 100% is showing your normal data. So this anomaly detection will be detecting in a similarity score form. So if it's 0, it's abnormal, and if it's 100, then it's normal signal. Like, the machine is working properly, and if some sound or vibration is there, then it will show you 0%, so which is your abnormal data. So this is your anomaly detection. So this can be implemented in different other forms. So this is just a small demo kind of a thing, how this anomaly detection works, how we can check the score, the similarity score for abnormal and normal datas. And like, this was, I hope everyone just got an idea about this Edge AI part. And thank you so much for like listening, and thank you.
Can you just show me where can we download this Nano Edge AI Studio? Can you just show us on the website?
Yeah, sure. Okay, sure, sir. Just a second. So when you go to this Nano AGI Studio software, you will get one option for Get Software. So you can download, go to the site also. Like, you can go to site, and so for your free version of Nano AGI Studio, you can register your mail ID through the mail ID, and you can download your Nano AGI Studio. So the mail ID which you have used for this registration, so in that email ID, you will get one license key. That license key, you have to like put it in like, when you open your Nano AGI Studio after download, you have to enter that license key in your software. So that part, you will be like, after that, you can use your Nano AGI Studio.
Okay, thank you. Okay. Ma'am?
Yes, sir.
Ma'am, I have one doubt. So
Yes.
in the board, there that Wi-Fi and Bluetooth module is inbuilt, or we need to connect separately.
Sir, in this board, the board
Yeah.
which I am using or I just showed you, it's just an embedded board. No Wi-Fi or no Bluetooth is added. But if you want to connect a Wi-Fi module to this board only, you can connect your ESP32 or a Wi-Fi, different Wi-Fi module to this board, and you can transfer your data to cloud. But if you want your Wi-Fi, a board for which has an inbuilt Wi-Fi module or a Bluetooth module, you can go for any other board, which like there are many boards which ST provides. It like AI IoT board, which can do your AI part also and can do your IoT part also. So there are many various boards.
Actually, I have another question. You say some different kind of machine learning algorithm is there. It is free or we need to pay for that algorithm?
Sorry, sir, can you just repeat the
Actually,
question?
after we give input to our board, there are some different kind of machine learning algorithm is there, right?
You have shown.
Yes, sir. Yes,
Yeah. While demo, you shown that.
yes, sir. Yes, sir.
Yeah, we need to pay or it's free.
No, it's free only. So, like in Nano AGI, after building your model, if you like, you will get some machine learning algorithms that will be inbuilt only. You will just get what algorithm, what machine learning algorithm this model is using. So I just give you example of audio classification. If you go for audio classification, the machine learning algorithms will be different. Like it will show you SVM or random forest. So these all machine learnings it will give. But for anomaly detection, it is ZSM, ICPA. So all these machine learning models, it's just free, sir. It's nothing to do with cost. It's just give you inbuilt. It's just inbuilt. It will just show you which model it's used.
Okay, ma'am. One more question. So, using this board, we can only do the classification set of problems, or we can do clustering or regression set of problems, or we can
Yes, sir,
only
we can.
do that single what
No,
you say
no.
that.
Anomaly detection or classification.
I'll answer. Already the tool is going to say, suppose you are learning. That means you are giving all sorts of signals. Here she explained one case or n.
Okay.
Okay. And it will segregate and give you the classification based on what you intend.
Okay, sir.
Okay. And you are also saying that this is a good signal and these are all the bad signals. It will be the classification.
Yes, sir. My question is whether we can use. Is there any possibilities to do regression kind of problems?
Say regression, when you use the regression,
Sir, for example,
for these applications where this particular tool, what the example she has given,
yeah,
it is only going for more of a predictive.
yeah,
That means you are going to learn it. This is okay signal, this is not okay signal.
okay,
Not a signal you are having. So it classifies based on the signal what you are going to give. Now you are going to touch it. What is the signal? Is it okay, not okay? It will say based on the whatever the feedback you already given,
yeah,
learning done.
okay.
It will say, if it is okay signal, it will say okay, based on that the inside the data which you have fed.
Okay.
If it's not okay, it will say not okay.
Okay. Just I ask, is there any possibilities to do linear regression kind of problems?
Hello, ma'am.
Yes,
Hello.
yes. Yeah, there is a possibility to do the regression type of model because you can see in Nano AGI Studio, I showed you, we have 4 different parts: anomaly detection, 1 class, N class, and extrapolation. In that extrapolation, you can build your regression based model or a prediction based model. Like regression based model, like ultrasonic sensor, like yeah, like I'm not able to hear the voice.
Okay, ma'am. Just continue.
We are little curious about how regression is going to be used.
Sir, like I have not started working on this regression model,
Okay.
but my like Yeah, so
Ma'am,
but it's there. Possibility is there.
okay. Ma'am, there is any limitation to use any type of sensors or any hardwares or whatever we can
No.
convert.
No,
What do you-
no, there is nothing. If you want to go for 2 sensors at a time, you can go just in Nano HI Studio. You have to select multi sensors, and that's all. You can connect your 2 sensors to it, and you can collect the data and build a model. Because, like some of the projects,
Pranali, what he wanted to understand is, suppose if you wanted to use ML tool inbuilt the sensor, then you have to pick up the sensor what you have defined. You cannot to use the sensor which is available currently in the market, you have to get that sensor what she has defined, some 32.
Yeah.
So that only you have to get it. That only you have to
Yeah.
get it. Is it in production or it's in C? It is in protos. Which phase it is, these sensors?
mm,
Is it in
like
series production?
production type, like
Are you sure?
it's
Are you
like,
sure?
yeah, yes,
Are you at protos,
I
proto
think.
stage?
Okay, ma'am.
I'm
Okay.
like not that, like I think it's production type only, but I'm not sure, sir. So like
Proto.
uh, uh
He's going to tell you also.
Okay, ma'am. Any other questions from online? 1 second.
Ma'am, can you show the interface of that the software? The first one. Ma'am,
yeah.
can you show that first interface of that software?
Interface in the sense like
Interface,
the
yeah.
setup.
That one shows one classification, n classification, extrapolation, that interface.
Okay. Just a second.
Anomaly detection is binary classification problem or different, ma'am? Actually, anomaly detection is 2-class classification, right?
Yeah, like abnormal and normal. You can only give 2 classes, like 2 signals over there.
Okay, and 1-class classification means we
One
have to
class,
give-
I will just show. See, in 1 class classification, there you can give only one signal. Only one signal you can give.
only that correct signal. From
Yeah,
that, how
only
can we-
the, yes, no, in this nothing is correct and wrong. Like only if you want to classify for ambulance or baby cry or normal dog barking or any sounds, you have to just give one signal over here.
Audio
So
signal.
just a second, I will show show you this audio classification. See, here in N-class classification, I have given my 3 signals: room noise, baby cry, and ambulance. Basis of that, my emulator will work. Like it will classify that
Okay, okay,
out
ma'am.
of these 3 signals.
Okay.
And if you want to check for the extrapolation, I will just show.
I understood, ma'am.
Like
Okay.
here, yeah. So the same. So
One more doubt is, ma'am, we have to give the input only by signals, right?
The application, it all depends on application. Suppose you have
yeah,
an application where you are going to give, you are developing a system where baby cry you wanted to capture. So if you already have a baby cry there, when baby cries, it will says, yes, your baby is crying to us. Go and take care of. Okay.
Okay, ma'am.
yes.
Ma'am? Yeah, one more question. So from the input, how to split train and test data and how to give an input? For example, as every machine learning algorithm, we give a 70 and 30 training and testing data as an input. So how to split the data and give an input to in that particular system?
Okay. So if you want to split your datas, so this for Nano AGI, then your Nano AGI software will be a platform where you will just collect the datas. If you want 1,000 number of datas, you will just collect that 1,000 number of datas. And after that, only collecting your datas, you don't need to build your project in your Nano AGI studio. Then you should go for your Python based model. Like if you in your Google Colab, Jupyter, you can develop your Python based model. There you can give the splitting method 70 or 70 30 80 30. That you can split your upload your datas, you can split that and develop the model over there. There you can check the accuracy.
Okay, okay, ma'am.
Okay, ma'am. Thank you very much for your explanation for all the questions. Any question from online
Thank you, sir.
participants? Any question from online participants?
You give the same signal. You tell this is abnormal.
Okay, ma'am. We can conclude the session.
Abnormal says if this signal is meant for engine. If you give that.
Hello?
It will tell you.
We can conclude.
Yes, sir. Yes, sir.
Okay, we can conclude the session.
Okay.
Thank you, ma'am.
Okay. Thank you.
Thank you.
Everyone. Thank you, sir.
Thank you, ma'am.
Thank you, madam.
Thank you, everyone.
Thank you, ma'am.
Thank you.
Hello, am I audible?
So good afternoon to everyone. This session will be handled by Mr. Nandakumar. And the title of Predictive Analysis for the Mechanical Engineering. So over to you, sir. You can start.
Yeah, hello, good afternoon, everyone. I am Nandan Kumar. I'm an application engineer from VVDN team. I hand over, I take care of all NI hardwares, and I suggest within depending on the required projects. And now today I'll be having a session regarding how to acquire data and what are all the platform to acquire those physical data. What the solution do NI have, and how NI is apart from stands apart from any other thing. Okay, let me share my screen 1 minute. Is my screen visible for everyone?
Yes, sir. It is visible, sir.
Okay. Yeah. I think my screen is visible now. Today we'll be having a session regarding what is data acquisition system and how can we integrate, how can we acquire the data from using a Labview. Hi team, I'm a application engineer, Mr. Nandan Kumar. Briefly, I'll explain you what is VVDN and what are all the steps VVDN is taking in the platform at the present technological market. Now, as a VVDN, we work with an 5G networking, Wi-Fi, and cloud and application development, as well as we work with Internet of Things and the vision development systems. Whatever the VVDN is it's an integrate. It has a separate OEM as well as also it works with an if we one have a design, VVDN works with for their design and to get an out product. We are located in 11 different designing centers in India, and almost out of globally we have a 6+ offices. In India, we have a manufacturing plants we have a Pollachi, Gurgaon, Noida. We have a manufacturing plants as well. In VVDN, there is a part of team called as a VVDL tool. VVDN tool is one-step solution that provides you an all solution regarding your all type of testing, measurement, and as well as your for your test requirements. The main thing is that in that system we have a NI. NI is a national instruments, and whether team we work with Weller, Kikuchi, Tasking. These are all we have a solutions for RF. Kikuchi is for power system, powers analyzers as well as loads, electronics loads. Whereas IGOS and Taskings are for software debugging tools, and the Pico and Segar are for your oscilloscopes, on different applications. In this whole team, as we support to the whole hardware like tasking, Veller, Seger, NI, where NI is an important hardware, where NI is for the NI, the VVDN is the only authorized distributor all over India. And we we need to have a support team. We have a support team for NI hardwares and as well as the repair systems we have. NI have a solutions and according to your application, we mainly have a solution to the control and mechatronics academic research. We have large scale experimental research we support, and we are as well as we work with wireless communication like 5G. And even we have the main important thing is the measurements and the instrumentation. Now let me start the important aspects as the today planned as a today agenda. To the I like the introduction to the national instruments. Once we come to the national instruments is an American-based company. It works with an international operations where it has an experience of about 40 years over the field of helping engineers and the researchers to solve their challenges in different platforms. NI have an automated test components as well as a visualization developed GUIs in the software, and even it have an communication application includes like data acquisition, instrument control, and as well as then RF communications. The NI's headquarters is at Austin, Texas. You may all know there are a lot of things happening in the present market in the field of test and measurements, as well as an EV, ADAS, as well as the 5G RF. In that circumstances, why NI is different from any other test and measurement system? That is where it comes a main important thing, why NI is more important and why NI stands apart from this any other company. NI have we have a modular based type of hardware system where these modules are very rigid to this environmental factors, as well as it has an IP rating of IP67, so they can be used in any moisture condition. And if the hardware is so rigid that you can use in a field like mines, as well as, and the main other thing is that this modular is like depending on your application. Like if you have a measurement of your accelerometer or like depending on your physical parameters, we have a different modules. These modules will be like chosen depending on different circumstances. Like some of the factors that we consider using these modules are sampling rate, number of channels, and what type of data it has to read. And these are all some of the factors that we have to add. And the main is like a resolution, what they want, like what the customer need to acquire this data are the main important factor of this. And the other thing is that we have an open ecosystem where if one has to like we have as your Facebook, we have an NI group or like NI community where we or like engineers or the researchers have a group. We work with an motto, like if one getting an error, it's not only our engineer or anyone has to help you. In the community, any person, whoever using NI and already achieved this, the present what you are doing, he can help you through this community. He may be not only from the local, he may be from all over the world. And the NI is like software obsessed. If in the present market, you would have seen that if the hardware is of one company and the software is of different company, and those things you have to integrate and then you have to use it. It is not exactly as you can use, you must use exact software and the hardware to get a compatibility. Such kind of misunderstanding or like mismatching will not happen in NI, as NI have its own softwares depending, we have like 5 to 6 different softwares. Once dependent on this customer need, we suggest the softwares. The main important platform for the development or the software is the Labview. Labview is the main important software where the most of the development happens here. And once we come with a test and measurement system, the main important factor once it comes to software, some may think like it will be like a long writing the code, keeping more logics, loop, more constraint towards the writing the code, then that will not make your project to acquire very fast. That is why NI have an like coding system where it is nothing but it is a graphical way of your coding, where it's creating your algorithm as your design or like a graph that comes to your mind. You can see in the PPT that the first is like we have a mind setup of like, this is the algorithm that I have to, or my program has to do. The exact thing what the algorithm has written can be depicted in the Labview. The bottom, like the screen is for the Labview that comes exactly as that of the algorithm that present in the graphical way. Even this helps with the main thing is that the debugging is very easy here. The exact error that comes at whichever the point, it depicts there and shows that what is the point of error that happens here. The other thing is that in most of the languages, you can see that there will be a backend front-end developer where this has to be integrated with both of them, and this need to be tested with a different tester. But Labview is that platform where the single user will be a front-end developer as well as a back-end developer. The exact GUI interface can be dropped down according to his wish or like view. He can have a graphical way or like a Boolean or like any indicator, what type of indicator you want to see in the front panel, he can achieve it directly by a drag and drop. The main another fact of this Labview is like the most of the processing algorithm, whatever you want to do with your data, as all can be done or like achieved directly in the Labview. We have almost like 15,000 plus algorithms. Each you can directly drag and drop them, and this algorithm as this pre-readied or like already been existing algorithm, you can easily drop down or like this makes your program to be easy and quicker, and you can achieve your objective very fast. Hello, am I audible, right?
Yes, sir, it's audible.
Yeah, okay, I'm proceeding. Yeah, and the main we have like different product line in the field of software, where the software depending on this like configuration will be dependent as the customer need. The main important software is the Labview. As you all see, the Labview is a programming environment. This is the base for all the software that has been that I will tell in the next slides. Whichever the software that like any other software in the next slides are like developed using the Labview only. Labview will be having two screens. One is the block diagram panel and the front panel diagram. where the block diagram panel, you will start developing exactly as your algorithm. And the front panel is that it is a GUI interface that for your visualization. You may all have that like simple like configuration, you want like plug and play type of acquisition of data. You no need of coding or anything. You are not intention to have like small coding also. Then comes a software called as a flex logger, where it is like directly plug and play your data. You can, if you want to achieve, like you want to have an objective of retrieving or like having a data and store it to some of the files, and you can do a very small operations of mathematical operation. If you want to do, then you can use a software called as flex logger. Flex logger is nothing, no code platform, software platform. You directly choose on whichever the channel you are acquiring what type of data, and you have to configure like which data from what is the range and from which channel. These things are to be mentioned, and whether it's a continuous sample or like an on-demand sample, you can choose there. And then you can choose a file path if you want to store it to some of the CSV file, Excel or TDMS format. Then you can choose a file path so that the data is to be stored in that particular file. After that, you can have a small trigger also. So to some extent, or to like for an example, if I take as a temperature, if temperature exceeds to some range, you can get set an alarm. These kind of small activities, and like conversion of your data like Celsius to Fahrenheit or Fahrenheit to Celsius or Kelvin, or like you want to do FFTs. These are limited to these. Flex logger is limited to those things. Like, but you have a more visualization impact here. So the more GUI interface is already being present at the flex logger, so you no need to have a developer code as per your need. Then there is another software. We have an Instrument Studio software. Instrument Studio software is the GUI really prepared to use your oscilloscope function generator and your visualization of any data. The storage of data cannot be done here. It is as this is an application software, you can significantly control your any hardware like PXI in NI, as well as your any multifunction cards from NI. Even the non-NI hardwares, like you have a Tektronix, Kitley, or like some of the oscilloscopes, or like some of the function generator like Kikuchi, those things, if they have an USB access, they can be controlled or like they can be monitored using this Instrument Studio software. Make a note that all these things, whatever the control or like what is flex logger is doing and the Instrument Studio is doing, these two can also be achieved using only Labview. But the need is you have to develop your code according to your functionality. And moving on to the next software important thing, the NI hardwares. The NI hardware is like vast. We have a solution for RF measurement in a platform of like from the large range. And even as our modules are very rigid, we have our modules up to 6 gigahertz of acquisition speed. We have mainly starting from a single USB plug and play device. We starts from there, that is an USB type of acquisition, to an higher end PXI systems. In the middle, we have like a series like USB DAC, then comes a CDAC, then comes a this PCI cards, then with the compact Stereo, and then the finally comes with a PXI systems. Each USB DAC is nothing but you'll be having a multifunctional type of data. Like you will be having like 2 analog inputs, 2 analog outputs, like some number of DIOs, or like if you have an like microphonic analysis, depending on the application, those can be also be used in USB. Then comes the CDAC module. CDAC is nothing but it is a like compact data acquisition kit. So you will be having a chassis, and depending on your application or like your need, we choose the modules so that you can plug those modules with the chassis and you can communicate with your hardware, PC. And then is a PCI card. This PCI card is like you can plug it to your PCI slots that are present at your CPU backside at the bottom. You can directly plug these PCI cards and integrate with the CPU and you can use. Then comes the Stereo. Stereo is nothing but your high-end data acquisition CDAC kit, but the only difference is that Stereo has its own. It can works with real-time operation with FPGA unit. Then to achieve a higher sampling rate as well as the speed and the resolution, we have a system called as a PXI. PXI is nothing but your CPU. It has its own controller, processors, and it depending on the mod application, we choose the module. In each CDAC or like Stereo or like PXI or like PCI or even in USB, in each application we have like 100 to 400 different types of modules. So those need to be suggested depending on your applications. In the PXI, mainly we have a solution towards an DMM, then with RF application, and that this whatever the it has been emerged to the platform to retrieve like to vanish the older methods of testing measurements. This are the some of the hardwares you can see here. Why NI ecosystem is open? You may all get the question. Why to have a choose like first option? If we in the lab we not only have an NI hardwares, right? We have like different measurement tools, like we have an oscilloscope, function generator, DMMs, or like any other things. Those all can be controlled using a Labview. The only factor is that whatever the hardware is that they will be having a Labview drivers that need to be installed on your PC. Then this whichever the hardware you want to control, you can easily control using a Labview. That is why NI ecosystem is called as an open source of ecosystem. Yeah, this is an hardware, like this is a basic first, like the second step of acquire part where it is an CDAC system. CDAC system is a compact data acquisition kit where the CDAC will be having a chassis, and you can see here this is a chassis. You can see we have a chassis of 4 slot, 8 slot. We have a chassis of 14 slot also, but most of the thing is a 8 slot has been suggested. Depending on if it's a small application, we'll have a suggestion of 4 slot. And then we choose the voltage or like current, or like it's an LVDT measurement, acceleration measurement, temperature measurement, or like any physical depending on the parameters that the customer suggests, we choose the modules according to the application. These modules have an we suggest the modules like we have a parameters of voltage range, sampling rate, resolution, and number of channel they need to measure. These are all the 4 important parameters what we look after once having a meeting with the client customer. Here, modules are like expandable. You can have a daisy chain connection if it is an Ethernet based of chassis, or like if you have an USB type of connection, you will be having another Ethernet slot So you can have a daisy chain connection if you want to have more than 8 slot to your application. These are like have an operation specification that can work for shock waves like vibration and even at the temperature range of 70 degrees Celsius also. The main thing like this have an integration with your Labview, Flex Logger, and even if you have an language code, if you are okay with your language code like Python, C or C++, or even with the .NET, you can control this hardware. This hardware is like you can connect your PC with your Ethernet as well as your USB type of connection. This will be having one power connection where it comes with 19 volt of power connection. Then it comes with one of the Ethernet, and the LED has been present to show the status of the hardware. This hardware is like portable. You can replug and you can plug it to any of your labs. It's a hand carryable hardware. It's like a benchtop small instruments to achieve your more bigger applications. The measurement is like comes with a very precious acquisition and combining of any number of sensors and the electrical measurements can be achieved very easily using an CDAC systems. Yeah, any doubts till now?
No.
Okay. And next comes the important hardware, the stereo. Stereo seems like looks to be as a CDAC only. The main important difference is that the stereo have its like a real-time operation. It works with real-time operation. So the processor will be there inside this controller. Even it has some storage memory. You can have it and you can have a connection with directly with your PC. Once you develop your code and if you dump the code in the stereo modules, there is no need of your PC to be connected for your application. Directly, this operates in real time and controls whatever the application you need to achieve. This works with only Labview. As this is a real-time operation, we need extra drivers. Those drivers are like real-time drivers, FPGA drivers. These drivers are to be installed in the stereo processor itself. Even once it is like logged in with your new stereo module, you have to dump all this code, all these drivers from your PC to this stereo controllers. These controllers are like chosen depending on like core type and the speed of what is the max speed they are looking. And this chassis also having compatibility with 4 slot, 8 slot, and even you can achieve a daisy chain connection if you require to have a more number of slots according to your application. They have USB, Thunderbolt, and as well as the Ethernet type of connection with your host PC to further communication. Here, these are like some of the mod in the picturization you can see here. If you can develop your load code in the Labview or like your algorithm, you can create your exe there. Then you can dump that exe in this inbuilt processor. So from the next time, you can directly connect your Ethernet or like USB to your monitor only, and directly you can visualize the data. Or else, if the data has to be stored to some of the location, directly you can connect this Ethernet cable and you can leave. This is an like more high speed than the CDAC acquisition, and even this is like more rigid and you can use it in any rugged applications also. These are like some of the modules that need to be plugged in at the Stereo or the CDAC application. We have modules of different application. We have a modules for temperature measurement, RTD measurement, whether it's a PT100, PT1000. Like we have a modules for strain with strain measurement on depending on what type of bridge it applicates, whether it's a half bridge, full bridge, and type of sensor. We have a modules for voltage input, current input. Then we have a module for acceleration measurement, pressure measurement. Yeah, depending on this applications, we choose these modules. In the C series measurement, we have a modules for strain and bridge inputs module, where you will be having modules as shown in this picture. It will be like dependent on number of channel. If one's customer need like 8 number of channel or like 4 number of channel, we choose the module and type of front connection, whether it's a spring terminal you want to have like Ethernet connected, or like it's RS-235, or it's a D-serve, or like it's a screw terminal. We have in the all modules, we have an option for all these things. In the strain is like important is that main is one is excitation voltage, what excitation voltage one sensor need. Our modules are able to give an excitation that the sensor need directly. That is why whenever we have a configuration or like suggestion, we request a customer or the user to share the specification sheet of the sensor they are using and the number of channels. And moving on to temperature data, we have a thermocouples module here to measure a temperature. We can use for any range of temperature measurement. As the range it depends on the sensor. If you share the sensor sensor specification, we can suggest the module depending on the range or like sampling rate and the number of channels. And the main important thing is that the modules differ for RTD modules and the thermocouple modules. And they have an inbuilt cold junction compensation that need for a thermocouples, and you can analyze all these data and store your data to any formats. Like you want to trigger even after retrieving these data, you can achieve using NI hardware. As these are input modules, these are like your input modules as they are acquiring your data. Then we can go for a further important thing is like sound and vibration input module. Sound and vibration module have its AC or DC coupling having an inbuilt which can be selectable at the software. And even these modules are able to excite your sensor. Like if it is a sensor is an IEP type of circuit, then it can have a signal conditioning according to IEP. So you can directly plug your type of sensor and you can acquire your data. Similarly, you have an voltage input module, current input module, as well as voltage output module. Voltage output module will be having a range in the two formats. Either it may be like analog output as well as your digital outputs. We have a range of plus or minus 10, 60, plus or minus 60 type voltage. Depending on the customer need, we configure the system here. Moving on to the high-end application, like high-end software thing, or like your hardware, we have an important hardware setup here, the PXI. The PXI comes, or like it's the PCI is the main platform to develop these PXI systems. PXI is like highly used in various applications where it's a manufacturing testings, automating the test, then machine monitoring, as well as your military and your aerospace and the semiconductor industries also. They have an high performance modular instruments for input and as well as your output. They have a specialized dependent modules where you can achieve till 1 gigahertz or like 6 gigahertz of data transfer. Your modules will be chosen. You can have a DMM, SMUs, then your as well as your acquisition can be done as in CDAC or CDO. Here, the main thing is that the DMM, oscilloscopes, then your SMUs, your RF generator, vector generator, vector analyzer, these can also be achieved in this PXI systems. As this is iron, quite costlier than those things. This hardware comes with a bigger controller. You can see here. Yeah, I can show you individually. So this is a chassis that comes with a PXI. This is like your PCI slot comes with your comes at the backside of your CPU. This chassis have an like 4 slot, 9 slot, 14 slot, 18 slot. So like number of increase will be chassis will be having increasing size. It increases once the number of modules are more. This they have the hybrid slot as well as a normal PXI slot. PXI is an like in the 2020s, before 2020s, now after 2020s, we having a new express, what we call as PXI express cards. These are more higher to achieve more higher range. We had a PXIe type of hardware. The first, what we call in the C, you can see as a red one of the slot. The red slot is meant for your controller. So the controller will be acquiring your next before the red slot, so that it acquires like a space of 2 to 3 modules. Even if one of don't want their controller or like they directly want to control this with their PC, then we can suggest this the small 4 slot chassis, where this is just an communication interference with your PC. So there will be no any controller. Directly an Thunderbolt or like Ethernet connection will come. You will in the red slot, you'll be having in one modules that is used for communication, and the remaining other slots can be used for your acquisition or like your controlling to automate your application. They have a very well key important feature is synchronization feature. They are like very they are also quite rugged for the application. Depending on application, we choose the modules, and these modules all have parameters of sampling rate, bandwidth, resolution, as well as the number of channels. If there is a option or like application to achieve more number of channels, like if you want to measure 100 quantities of the thermocouple, you can directly use 1 card or 2 cards here, and you can get 100 values of thermocouples if you have. Then comes the controller, which is called as a mother of this PXI systems. We have a PXI controllers, where these controllers having a inbuilt RAM as well as the memory here. We have i5 Xenon i7 processor inbuilt for according to your applications. This have a communication interference with USB, Thunderbolt, and Ethernet for your application, and directly your mouse and keyboard can be connected to these computers. and you can even have a trigger from your PXI systems using these things. Even this required your real-time and FPGA modules as the CDO systems. We have almost 600 different peripheral modules. According to your application, we suggest which card suits for this application and we suggest for those. The main dividend or like platform here comes is that 3 important parameters is like in PXI, whether it is like data acquisition and control application, or like instrumentation application, or like an interference application. Then in the each category, once we come with the data acquisition and control, we can have a control over there as an whether it's a digital, analog output, or like counter or timing synchronization, or like vision monitoring or laser monitoring type of data. Once we come for instrumentation, we have an signal generators, SMUs, DMMs, oscilloscopes, RF analyzers. Then the interference will happen with an GPIB, USB, then SCXI, Ethernet type of connections here. The workflow for the test and measurement using an NI hardware is like we have a hardware and how to use it within your PC or laptop. For the CDAC, USB, PCI cards, if you want to control these things, you need your laptop or like PC that with your Labview or any one of the software like FlexLogger or like Instrument Studio. The main important thing is that we have an NI Max NI measurement and accessory driver. That thing is a main important thing to check whether our hardware is working fine or not before we code or do anything. The main important factor of application is data acquisition. In data acquisition is your sensor, data acquisition device, and your connection. The NI device have its own signal conditioning as well as A to analog to digital ADC converters, and in the computer the main important comes with the driver software and the application software. Application software comes here as an Instrument Studio and the driver software comes as an NI Max, NI Visa, IMAQ Max, vision modules, like sound and vibration analysis. These are some of the driver software that comes with for your application. Then this is similarly, you can control your non-NI hardware here. You can use your USB, Ethernet, or GPIB as well as your serial type of communication cable. So using Labview, you can control any hardware with the connection of you through USB or like GPIB or like serial, anything. The main one thing to be noticed here is one has to have a driver of that particular hardware. So you can call that function or like call the algorithm in Labview and you can control that. Or else we have a directly. So once you develop or like download a Labview, you'll get a NI Visa driver. There we have an NI UI designed or like not only for one application, it is designed for an overall universal attack kind of controlling application that has been developed. You can use that also. And next comes the part like data acquisition and validating using an NI hardware, and how and what is the process of acquiring the data, or like we can see here. As you all know, in the previous slide, I have told you how NI have connection or like data acquisition system have connection. It's a C sensor as well as your DAC comes in the middle, and the computer have a communication with your DAC and to acquire those data. Typically, we all know that we have two type of signals. One is an analog and the digital signals. We have an analog as well as it's an voltage or like current. It may be a continuous. It may be like sinusoidal or like triangle or any type of signal it may be. Then comes the digital. It only has the two states, whether it's the 0 or the 1. Usually it's an voltage only. Then it comes with an analog input data. Signal from sensor is nothing but it's a type of analog data only. It will be like continuous, that this voltage will be like, or the signals will be read from our NI modules. Whatever the signal conditioning required, that will be automatically done in our hardware. This hardware will be connected to the laptop. In the laptop, we configure, like for example, we take as a temperature data, as we have an temperature modules of 8 channel, 16 channel. If we plug in 16 channel, we have to configure in the system that from which channel that we are acquiring the data, or like I want the data to be seen, or like I want data to be stored in any of the formats. We have to choose the channel, which channel, and what is the range, or like what is the type of thermocouple we are using, whether it's a K type, T type, C type, what type of thermocouple we are using. And it's an cold junction CJC value will be inbuilt if you have an option for that, or like if you want, you can develop a code as to log your data to some of the format, as well as your you can control the data with the time specified also. Thus, these are some of the examples where analog input signals are measured, like high frequency voltage signal, accelerometer, microphone data, like strain gauge, as well as your current measurements. Analog output is like you're controlling, you are used to control some of your parameters, or like some of your drivers, or those drivers will be controlling your motors. We have an analog outputs of different voltage range, like it may be a 5 volt TTL, 24 volt digital, or like it may be 24 volt analog output, or it's plus or minus 10, or like plus or minus 30, plus or minus 40, or it's like 60 volt. Depending on these things, you'll plug those modules and you can control on your application here. We have a function generator like voltage ramper for an analog output. Here is a simple example of an voltage looks like what is then RPM value, or like if you can consider the fan speed, you can have an controlled voltage to control the speed of the fan. Then this function generators, which are from NI, we have an virtual bench as well LV3 boards. These are like function output voltage, or like function generators at PXIs. We have simulated signals for a unit and a test for like in any form, like if they want like sinusoidal, square wave, or even triangle wave can be achieved using NI hardware. These are some of the digital inputs. In some of the sensor, we have a digital inputs as well. So directly as well as this analog input measurements, we connect this hardware with our CPU, or like PC or laptop. We'll have acquisition or the hardware. Then we can also have an analog. These are some of the example of digital inputs, how it looks. And the main other thing is an digital outputs. We have a digital output modules as well. These are like we have modules of 5 volt, 10 volt, and 24 volt. Whether it's a normal, it's a high or low value, or like if they want a TTL type of signal, we have a modules as well for a TTL kind of signal as well. And then it's you can switch, or like trigger, or like generate a protocol signal using this digital output module. Yeah, any doubts till now?
No, sir. And
Yeah.
I have one small question, sir. Should I ask it right now or after your session?
Sorry, sir. Yeah, you can ask it, sir.
Okay, sir. So, while doing such operations like welding and other things, while arc is striking, we have very little amount of vibration. Does your sensor having the capacity to measure those vibrations?
See, we don't prescribe for sensor. Our modules, we are not expert at the sensor. We
Yes.
can suggest the sensor once we have a detailed technical discussion with you.
Okay. Okay,
Okay.
sir.
And whatever may be, it may be the minute signal, we can draw those data using our data acquisition kits here.
Okay, sir. Thank you.
Okay. Yeah, shall I proceed?
Yes, sir. You can proceed.
Yeah. Then the important is like how software works, how will be your software, and till now you have gone through how the hardware will be and how it is being connected with your hardware. And then comes the software. Software will be the Labview. This is the Labview is like platform where you can develop according to your applications. Where this flex logger like Instrument Studio are ready to have food. They are like ready to have food. You can directly plug, you will install, and you can start using without any of your coding knowledge. In Labview, you'll have a latest version of 2023 Q4, and you will have a main important some of the drivers is Labview runtime, NI package manager, NI license manager, and NI Max. These four are the basic drivers that are need to be installed in any of the PC to use any NI hardwares. If you want to additionally use any non-NI hardwares, you need NI Visa there to be installed to acquire or control from any non-NI hardwares. You can see how an NI Max will see at the first page. NI Max is like configuring or like connecting your NI hardware as well as non-NI hardware also be connected or like shown before your actual coding starts. The first screen of NI Max, once you open NI Max, looks like this screen where you'll have an information about your PC or the system. If it is an PXI or a stereo system, the system resources or like system information will be there, that value of that processors. If it is an PXI system, the information of memory, then total physical memory, name of the system, and for what is the present running or like what is the CPU model, everything information will be shown here. Then we have a device and interface there, the option where if you click on that arrow mark, we'll be having two options. One is network devices and another one is USB devices. USB devices or like network devices. Network devices are like you can connect with your Ethernet cable. If your lab at different part, like beside or at the same Ethernet connection, you can connect at your sitting position with the Ethernet and you can access your hardware from there. You can whatever the modules that are present at that chassis will be detected in devices and interference, exactly showing which module is present at which number and which slot. Like if the first slot is having temperature measurement data and the 8th slot is having voltage input data, exactly it will show at the first measurement you have a temperature measurement module like 9212 or 9210 or 9213 and this serial number that is unique for each hardware. And then is a software option. You can see there the software will be having then software list, what are all download here. And the remote system is like to access your remote through Ethernet cable. You can connect through your IP address and you can have a acquisition or like a control or like your automation. This is like in a previous slide I have discussed how we'll connect the sensor. Sensor comes with the DAC, then DAC comes with the computer. and even this is acquiring of your signals as your sensors. You can see what has this NI, our NI modules have their inbuilt signal conditioning. Depending on each application, we have different modules. We have in that modules, we have this many signal conditioning happens. If it is a thermocouple type of module, it will be having an linearization amplification and CJC's signal conditioning happening there. If it is an RTD, current excitation required and linearization will be happen. No need of any extra signal conditioning modules required once you connect with our NI hardwares. Then in an analog input, the main important factor comes as a sampling rate. Sampling rate is nothing but your number of data that you are acquiring in 1 hertz, like in a frequency in per second. This is more like concerned when you comes with higher application, or like if you want to acquire more number of data at one instance, you have to use more number of sampling rates. According to Nyquist criteria, you may get there. It is like if you want a proper signal to be analyzed, you want like minimum of 2 times of the frequency, but if it is more than 5 to 10 times, you will get a more very good accurate signals happens here. You can see with an example for us actual signals frequency and with an acquired signal by our DAC. If it is like a normal 3 is the 3, if you heard if the signal is aliased, if it is like a 2 times, you'll be having only 6 data. These are like not adequately a good signal. It is like very sharp. And if it is like more than 5 or 10 times, you can see here your signal get more sharp, sinusoidal or like smooth. Even if you increase more than this, you will be having very smooth and the loss of data will be very less. Now, as you have like gone through how can I what is the main overview, how we can acquire these data or like process your data. Now, in next, I'm going with how to develop a small code to acquire your data and analyze your application. Here in NI Labview, we have two screens. One is block diagram and front panel. Whatever the coding you want to do, you have to do it in a block diagram. In the instrument acquisition, you will have an first input parameter as your configured channel. What type of data you want to achieve and from which pin you are acquiring the data. Then the VIs comes is the start VI, then is an configure VI, then is a clear VI. Then the first VI is you will have an start acquiring from this pin, so that the thermocouple it is mentioned here, and the middle comes with a read option. What type of data it is reading from first one channel of data, and only one sample is enough for me. If it is an N sample, you can choose as an N sample there. Then you have to clear the data and you can exit it. Here, the read data after reading, you want to be indicated, right? You can see that current temperature, there is a block, right? The current temperature block can be converted to your any format. It's depending on if you want to have a visualized data in graph, like you want to store that data to some of the Excel format with respect to time, then you can put a column function there and you can draw it. This VI is simply designed to have a small indicator message if the temperature exceeds some threshold. Here I have an condition here, like if it is greater or lesser to some of the maximum threshold, then show me a message of threshold exceed. whether this message may be a return statement or it may be a Boolean indicator, or even I can give an output here so that it some voltage has to be come out, and I can give it to some of the fans to reduce the temperature as well. Then if it exceeds more than this, even I can show, I can write, I have written the code here as a normal, like system is overrating, please turn on the fan. This kind of message can also be written here. This lines, colors, and the thickness will be having, all this will be having different meanings. And this Labview training is like Labview learning will only have a training session of 5 days of long training. Okay, and next, this is a simple acquire part. As I showed previously explained the overview, I'll in the step by step have been added in the PPT. That's all here. You can see this is the first part is an acquire part. Then the below part is analyze part. You can see analyze the data. Like this is a simple example. You can do it to as part like as your application. You can see here some of the message indicator blocks that comes once you drag it to the block diagram panel. This indicators come and automatically they come and place at the front panel diagram. You can see I have an like scale type of UI. If you want, you can change it to thermometer or like indicator thing, or like speedometer kind if you have a speed measurement, and you have an indicator block here. I have a Boolean expression here and this message block. So it depicts the message, system is normal or like system is abnormal kind of thing. And the main is an error out. Error out is a front panel UI. If any error at the code is done, then this error status will turn into red, and in the block of code it will generate one code that will be some numeric. It will be sometimes alphanumeric as well as most of the time it will be a numeric. And what is the source of error, where the source is error is generated, that information will be depicted in the part of source there. Then so that you can in the code you'll be having some numbers, you can copy paste that number in Google, or like NI community, what I told, we have a common platforms. You can dump that error. You can get an like why this error is coming. Like someone can suggest you, like will help you to come over those error. Even as most of those errors has been common, they already been dumped in the Google, so you can easily achieve or like go ahead of that error and you can achieve your objective. Then we have 3 types of acquisition part. One is a full API approach. Then comes the task method, and then is a data acquisition VI. All these 3 are like having the same or like same objective. The only thing is that the configuration panel and the code method of coding, that's all. In task method, we develop a task in NI Max and we directly call that function to retrieve the data from that task and to store or read it to some of the formats. In full API method, we have a choose option of changing any of the configuration data, whether it may be maximum or minimum value, or it may be the channel, which channel, like what is the sampling rate you want to. These things can be controlled at every time in front panel. If this need to be done, you can use this as a full API method. And another comes and simple ready VI is data acquisition VI. You directly drag the data acquisition VI as all the start, read, clear, configuration, everything is inbuilt, and we have created an VI there that you directly have to give a configuration from which pin to which pin you are acquiring your data and where data need to be stored or like it has to be indicated. That is a simple one. You can do it here. This, whatever the full API approach, these are some of the VIs that are at Labview. This is the difference between how your NI full API as well as your task method looks. The first one is a task method. The task will be created in NIMax. So it will be directly called here with a start VI. And whereas in a full API method, you can have a control at your sampling clock and your types of like reading the data, and you can have a configuration change at any instant of time in the front panel in full API method. This is how we are the simple steps we need to follow where you are during the acquisition. And next come, you acquired your data, then you want to read it to or write it to some of the file. Here are some of the, you will have an array, different types of array you want to do, you can achieve it here. If you can directly here, I am calling a text file column headers. So that need to be stored in the file path. You can see the file path, low level stream to text file. So I have called one file path here. So I'll drag the VI and I have connected the file path there, and whatever the read data is there, it has been array to spreadsheet string. You can see there the data is first I'm seeing it as an waveform to see as a visualization. Then you can see there I'm writing a file like data. This array spreadsheet is written to one of the file and the file path is connected here. Then the other software is where if you don't want these kind of codings and all, next comes the Flex Logger. As I have seen here, Flex Logger is a software where it's a directly integrated type of software. No need of your any coding language, coding knowledge. You directly configure the pin. So if you want to be like, for example, first channel of 9212, you want to measure volt temperature, you directly choose that and what is the range and what type of thermocouple you are using, and you can start the acquisition. Directly you can give one file path here name, and you can that automatically you can see your log specifications as a second option. So you can see the second option, choose the second option, and you can copy paste one of the file location, and that from once you run the code, run this Flex Logger, after saving, the data will be stored in that particular location. In the beside, you can see there is an option called as screen. So if you want to visualize the data at that instant, you can have a graph, indicators in different formats like speedometer, thermometer, anything can be drag and dropped here also. Why like Flex Logger come into picture is like this software, whatever the troubleshoot is there, if some will be having whether my code is working like fine or like can I do it or like, then comes Flex Logger. So you can directly plug and no need of your any troubleshooting techniques to be done or like coding to be done here. And as it is like directly plug and play, it's a faster measurement you can do. And this in like you can plug any number of any type of sensors directly, and you can choose those configuration and you can acquire easily. As these are like some of the same parameters as I told you, the data can be, you can have an input as well as your output trigger can be used in Flex Logger. Some of the mathematical operations of can also be achieved in Flex Logger, not to the more extent. Those are like limited to some of the extents, and you can store these data in TDMS as well as your CSV files here. This is how an overview of like data logger streams looks. You'll be having DUTs, sensors, data acquisition kit, and data management tools. All these data management tools are and there is no limit in Labview, but there is a limit constraints in Flex loggers and Instrument Studios. This is how your Flex logger screen looks. You'll be having a channel specification. You'll choose the channel, which channel and which type, and you'll choose the TDMS format, what type of file location where you want to log the data. Then you'll choose any events or like any trigger has to be done at any extent. You can choose here. Then comes the screen option where you can visualize your data to graph like speedometer, thermometer, or anything. You can see our data will be logged in the channel constraint here, and this is how it looks at the point of view. Thank you. Anything?
Thank you for the presentation, sir. Any question from participant side? You can unmute yourself and you can ask the question.
Or else you can, for online participants, you can put the queries in the chat box. We will transfer it to them also.
Yes, sir, you can do that.
Sir, for me, I have a few questions. So
Yes,
since
sir.
I was working in welding, sir. So welding instrument, they have different type of ports. And for your NI system, do they have any customized ports to integrate with the welding systems and any other modules?
So see, sir, here we have a solution for your any of your measurement. If you have your type of sensor, okay.
Okay.
Because I'm not an expert at the welding part, but I'm an expert at the data acquisition team.
Oh, okay, sir. Actually, they will study BI characterizations by using the.
Okay, then if that is the thing, you can explain me your application post this meeting. So my email is being displayed here.
Okay.
You can take the photo of the email, so
Sure.
you can get back to me, so I can suggest you the better solution there.
Okay, okay, sir. Okay. Thank you. Any other queries from offline participants? Any queries? Online participants, any queries, you can drop it in the box, chat box. I think. Any queries? I think there is no queries, sir. Naveen?
Okay, sir, we can conclude this session, sir.
Yeah, thank you for this great opportunity.
Thank you. We have also learned so many items from you. Now only I'm getting new ideas for integrating the welding with some new outputs. And hope we will come back if I'm getting any project. Thank you, sir.
Definitely.